right, next up, please welcome Federico from Lambda class.
I don't want to make you more sleepy. I'm already sleepy. So the idea is to talk about StarkNet and Lambda class and what we're doing. So this is me. I'm my intern. Many people ask me, where's Fede? I'm Fede. That's only my Twitter. That's my webpage on our blog. In our blog, if you like mathematics or distributed systems, you can read quite a few interesting things. So the core idea of what we do is engineering. We do engineering in many aspects. I wanted to talk a little bit about the engineering work we're doing in StarkNet. These are the 4 main projects we're doing in StarkNet. The last one, actually, it's a little bit more huge. It's also useful for other blockchains. So we did Cairo RS, StarkNet in Rust, Sierra 2 MLIR, Lambda works, and in the future, the sequencer. So what's Cairo RS? Cairo RS is the virtual machine that generates a trace to be proven by a prover. It's pretty complicated. This is the documentation we wrote to understand what StarkWare created originally. There was no documentation about how it worked, or at least publicly it was not available, so we had to reverse engineer it. StarkNet in Rust, it's something that is on top of Cairo RS that lets you create transactions, blocks, store things, and create contracts. It's also pretty big. Then you have Sierra 2 MLIR. This makes Cairo as fast as C. It's not provable, but it makes it really fast. The last few days, we published a few performance analysis. The one on the left is Sierra 2 MLIR. It makes Sierra way faster than Python. I mean, like normal Python. It's almost as fast as C code. So this makes Cairo at least 100 times faster than running Cairo code on top of Cairo RS. On this is some improvements we got like the last few days, 30% improvement more or less in different operations in Cairo RS thanks to the Lambda Works backend. So on Lambda Works is the prover. We're working on an alternative prover from Sharp. We're still learning a few things that StarkWare is teaching us. We're also working on some implementations of FFT, of Fourier transform, something needed for the prover to be parallelized into mini computers. But the question is why do we need this? There's I don't know, hundreds to thousands of blockchains. Why another blockchain? So from my point of view, most of them are pure bullshit. They're just a modification of Go Ethereum. They just changed, I don't want to name names, but they took the code base from Ethereum. They changed 2 or 3 parameters. Instead of having many thousands of nodes that can be launched by anyone, you can only launch them if you're approved by the network. So I don't know, that's not a blockchain. It's just a database. You need approval from somebody to be able to launch a node. You're creating the database. Most of them, the only thing they do is they lower the number of nodes. Instead of being able to launch thousands of nodes, you only have 100, and that's why it's faster. Most blockchains that are cheaper and faster than Ethereum, they are either because they have less number of nodes or because they need bigger hardware. If you need bigger hardware, it's not a blockchain again, because the core idea of a blockchain is that you can do things on top of it without getting censored or without getting an administrator modifying the state that you created. So from my point of view, blockchains exist because mathematics and cryptography wasn't powerful enough a decade ago. I will explain that. Yeah, so this is in part one of the reasons why, from my point of view, StarkNet is unique. The core idea is that you do the computation outside your chain and you verify it on chain. The issue was that until a few removing StarkX, that is a particular use case, the issue was that this wasn't very fast. All the L2s that are using CK or even Zcash, the first one, are not really fast. In theory, all these new CK or validity proof were going to make things fast, but in most cases, that wasn't still the case. Because of mathematics, but also because of engineering. And I think that's changing. StarkNet, in the next few weeks, will be the first blockchain that will be able to do more than 100 TPS without changing the hardware requirements or lowering the number of nodes. You will be able to have the same number of nodes in Ethereum, so you will have the decentralization of Ethereum, but you will start having the speed of Solana. Not yet, it's a little bit far away, but I think that in the next year it will be possible. So what you have, like, what makes StarkNet unique is that it achieves the performance of more like Web 2 systems, but with the decentralization of Ethereum or real blockchains like Bitcoin and Ethereum. So how do you do that? So you have fast execution with CR to MLIR. You re-execute everything on the sequencer, like Ethereum does, like it has re-execution. Then you generate the trace on the prover in the future. On that work cannot be parallelized, so it's really important that it's really fast. That's why we are still keep on improving it. And then you can parallelize all the prover, and you verify it on the other one with a really cheap machine. I believe that long term, most of the things won't be on blockchains. What Thiago should explain actually is not in a blockchain. Like what Thiago is building, or his team is building, is the ability to create bridges on different types of applications that won't need a coin, that won't need a blockchain. So I think that validity proofs or probable computation will solve the same issue that blockchains want to solve. That is the ability for people to transact and to create or execute code without needing a trusted party in the middle, like we do need right now with accountants, with the state, etc. But the interesting thing is this will be done with mathematics rather than only distributed systems on economic incentives. So I'm pretty sure that in the next few weeks, when this gets really fast and really big, it will be really easy to see that StarkNet is one of the unique players in the ecosystem. On probably next year, that will be even more clear. So if you're interested, I can explain anything that you want, or you can talk to me to explain how this works. But the core idea is asymmetry. Like you execute things on the sequencer, you send it to the prover does things very fast that on the trace generation, on the proving gets parallelized, and that gets verified. The important part is that if you don't verify things, you are not a blockchain. So this is a blockchain, things that are fast, but need approval from a central party, from my point of view, are not blockchains. Questions? Yeah. Oh, sorry. Yeah, sorry. Sharp is the prover. Is the prover by Starkware is the shared prover. Like that's the acronym actually. So you send everything that gets executed, then needs to get proven to be verified in the other one. So that's Starkware provides that as a service, but in the future that will be decentralized. The good part is that you don't need to trust the prover because the contract that verifies everything is on the other one. For now, the proving on the sequencer is centralized, but in the future it will be decentralized. These things will be copied by most